So now we're going to remember the formula of differentiation. Alright, so one by one I'm gonna explain. I'm not gonna explain you, I already explained you. So one by one I'm gonna tell you the formula for differentiation. So let's start with the derivative of a constant function. You know that the derivative of a constant function is 0. Reason, because like if there is a number like 6 or 7, so you know that these are constant functions, and if there is 6 written somewhere here, suppose over here it's written over here that is 6, so it's never gonna change with time, with anything else. So the derivative of a constant function is 0. Now moving towards the polynomial function, there is one just simple formula, that is x to the power n. It is equals to, means the derivative of x to the power n is equals to n into x to the power n minus 1. Now we have a very nice function, that is e to the power x, exponential function, and it's a very nice function. It doesn't matter whether how much time you differentiate it, the derivative of e to the power x is always e to the power x, and even the integration of this function is e to the power x. It's a very amazing formula. So now moving towards the trigonometric functions, the derivative of sine x is cos x. The derivative of cos x is minus sine x. The derivative of tan x is secant square x. The derivative of cot x is minus cosecant square x. The derivative of sec x or secant x is sec x into tan x, and the derivative of cosec x is cosec x into cot x, but in minus. So we are done with the trigonometric functions derivative. Now I want to discuss the derivative of inverse trigonometric function. So the derivative of sine inverse x is 1 upon under root 1 minus x square, and the derivative of cos inverse x is minus 1 upon under root 1 minus x square. The derivative of tan inverse x is 1 upon 1 plus x square, and the derivative of cot inverse x is minus 1 upon 1 plus x square. The derivative of sec inverse x is 1 upon x under root x square minus 1, and the derivative of cosec inverse x is minus 1 upon x and under root x square minus 1. So we are done with the inverse trigonometric function also. Now there are some important derivative formulas that I'm going to discuss in this video, that is like the derivative of ln x is 1 upon x, and the derivative of log x to the base e, not to the base e, a. The derivative of log x to the base a is equals to 1 upon x times ln a. Integration of x to the power n with respect to dx is equals to x to the power n plus 1 upon n plus 1. Now we're going to the integration of exponential function, that is e to the power x with respect to dx is equals to e to the power x only. Earlier also I told you that whether you differentiate this formula or you integrate, it never changes. Now the integration of trigonometric function, the integration of trigonometric functions. So integration of sine x is cos x, alright, that is minus cos x. So integration of sine x is minus cos x, and integration of cos x is sine x. Now integration of tan x with respect to dx is equals to log sec x, and integration of cot x is equals to log sine x, and integration of sec x is equals to log sec x plus tan x, and integration of cosec x with respect to dx is log cosec x minus cot x. So right now I'm gonna discuss the very important integration formulas in this video further. So that is integration of 1 upon a square plus x square with respect to dx is equals to 1 upon a tan inverse x by a plus c. What is c over here? The constant. You might be knowing about this. Now further, integration of 1 upon a square minus x square. The trick to remember is first you write 1 upon 2a, then you write log, and a was at the beginning, so over here 1 upon 2a log a plus x by a minus x plus c. Similarly, integration of 1 upon x square minus a square dot dx is equals to 1 upon 2a log x minus a by x plus a. Now the denominators are same, just we are gonna root over and let's do it. So integration of 1 upon under root a square plus x square is equals to log of x plus under root a square plus x square. Now integration of under root x square minus a square is equals to log of x plus under root x square minus a square, and integration of 1 upon under root a square minus x square is sine inverse x by a plus c. Now I'm going to discuss integration of under root a square plus x square dot dx is equals to x by 2 under root a square plus x square plus a square by 2 log of x plus under root a square plus x square. Now integration of under root a square minus x square is equals to x by 2 under root a square minus x square plus a square by 2 sine inverse x by a plus c. Now integration of under root x square minus a square is equals to x by 2 under root x square minus a square by 2 log of x plus the root x square minus a square. I want to tell you, but before that let me tell you what is the integration of a to the power x with respect to dx is equal to a to the power x divided by log a. Now we are going to discuss